Hey guys, welcome back. We're talking about imaginary numbers today. You should know that in your calculator, if you were to type the square root of a negative number, you would get a domain error. Well, that's just maddening. But all calculators aren't like that. There are some calculators, you take the square root of a negative number and you get the answer. Not a domain error. That's just sad. Some calculators' domain is the complex numbers, and some calculators, like this one, is the real numbers. Now, what we're studying is the subset of the imaginary, of this complex numbers called the imaginary. Remember that simple subset? You might be thinking, well, why is this stuff useful? How do I process it? Blah, blah, blah. Well, that's what we're going to learn how to process it. And the processes are used in some fields of endeavors. It might be that you want to become a nuclear operator on the USS Illinois one day. And you might have to go to nuke school, and these processes might be taught there. Not quite sure how. Okay, so we've got this little diagram thing where we're going to spin this little spinner. Well, we got to explain the diagram first, and it begins with a definition. The square root of -1 is I. Square root -1 is I. Some mathematician decided that that's what its name is going to be. We thank them for that. And then we're going to build on that with a couple of facts. Any non-zero number to the 0 power is 1. If it were negative, you would have to put it in parentheses. But I to the 0 power is 1. And remember, this is I right here to the 0 power is 1. Pretty simple. Fact number 2, any number to a power of 1 is itself. There's the banker's number. E to the 1 is equal to E. 100 to the 1 is equal to 100. Well, the same thing over here with I. I to the 1 is equal to itself. Pretty simple fact. And that builds out the first two pieces of our clock or our diagram. What this means is I to the 0 equals 1. That's the power. I to the 1 equals I. The result is that yellow portion on the inside. So let's see if we can build the other two pieces. I squared equals -1. You're going to see that so many times you're going to just memorize it, but let's try to at least see why it is. It's in the expansion. I squared is equal to I times I equals root -1 times root -1. When you do all of that, all that cancels is the radical. It's really tempting to say a negative times a negative is a positive, but that's just not true. If they're under the radical, just the radical goes away. And by that fact, we get the next piece of the clock. You may want to pause the video and read these slides. I just said those. And that's what this means. This means, whoops, I to the 2 equals -1. And that's a fact that you may want to remember. So let's move to the final portion of the clock here. That means I to the 3 equals -I. You're probably going to want to remember that, but let's build it. I don't really want to spend a whole lot of time in here. If we expanded it out, then each one of these would become a root -1. Well, we just saw that these two became a -1, and then we've got that one left over, and so we bring it back down to an I, and the answer is -I. The next couple of slides are just what I just said, and you can read those if you want to. Pause the video at your discretion. Let's get to a few problems. Okay, that's what we've been going over. That's a review of it. Well, what if the power is greater than 4 or 3? Well, that's what we're working on. It's just a matter of spinning the spinner. So this is what I mean. We're trying to go to 11. We start with the spinner at the top, pointed at 0, count to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the spinner ends up in this direction. That's the answer, -I. Everybody can count to 11. You can do that. Well, now we're counting to 18. That was so much fun. I'm going to count to 18 again. Now, we want to take shortcuts, but let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I may just do this all day. All right, that was -1. But obviously, we don't want to count to 24 or 78 or whatever. I want to emphasize the top as I count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Multiples of 4 are at the top. 24 is a multiple of 4. So I to the 24 is equal to 0. Equal to 1. And so what we're saying here is that I to the 24 equals I to the 0 equals 1. Let's do 30. We should know that I to the 28 is at the top because 28 is a multiple of 4, and then we count to 29, 30. So or you can count to all the way to 30 if you want to. And what this means is I to the 30 equals I to the 2 equals -1. The answer is the yellow portion on the inside. Number 5, counting to 37. So let's see, let's say 32. Let's say you don't get close enough to 37. It doesn't matter. You just count to 37. 32, 33, 34, 35, 36, 37. You just go an extra loop. And so I to the 37 equals I to the 1 equals I. And the answer is A. Keep in mind at Socrative, if I were to talk about number 5 or number 1 or number 10 or whatever, that's what I mean. And that is what the answer would be. I to the 55. And I'd say, well, gosh, 55. I don't want to count to 55. So let's do 48. 48 is a multiple of 4, 48, 49, 50, 51, 52, 53, 54, 55, and we end up in this direction, and the answer is -I. So I to the 55 equals -I. All right. Man, I'm having a lot of fun. And then, so let's say we got a big number, like 112. Well, because 100 is a multiple of 4, you only have to look at the last 2 digits. So it doesn't matter what that is. We're saying I to the 812 equals I to the 112, which is equal to just I to the 12. So we really only need to do I to the last 2 digits. Well, 12 is a multiple of 4, and so the answer is 1. Now, it's sort of the same thing, 263. It doesn't matter what that is, 963, 863, 1,063. Look at the last 2 digits. And you say, well, okay, I know that 64 is at the top. You can count backwards. Go counterclockwise, and you'd be at -I. Number 9. All right, I've been doing this a long time, and I know that every time I throw a negative in right there, it messes people up. So I'm going to blot it out for a minute. That's kind of what you want to do. Blot it out. Just do 23. Well, we know I to the 24 is at the top because 24 is a multiple of 4. And then go back to 23 and say, oh, the answer is -I. But then you have to remember that you have that extra negative right here. Bring it down, and the answer is -I, which, of course, is +I. Let's look at a few more problems, some types of problems that are going to be coming your way. All right, we're multiplying 2 numbers here so that you'd multiply the coefficients, 4 and 6. You should know to add these, so it's 24I to the 5. Well, let's count the 5. 1, 2, 3, 4, 5. So that I to the 5 becomes just I, and bring down the 24. The answer is 24IG. I believe you can do that. Something like this, you kind of want to rewrite this as root +36 times root -1. And everybody knows that root +36 is 6. And by definition, that's I. So the answer is 6I. You'll get a lot of these, so be prepared for them. Let's do a couple more. I'm going to bring that over. And then I'm going to just kind of what I just did. I'm going to rewrite that as root +36 times root -1. So this would be equal to -I times 6 times another I. Well, these i's go together, and we get -6i squared. When you do imaginary numbers and you have a power of 2 or more, it has to be simplified. So that becomes -1. You really, really, really want to recognize that I squared is -1, and the final answer there is +6. I have a few. I think this may be the last one of these. I went ahead and set that up to red, and I set this up to blue, and this would become 2. This would become I times that becomes 4, and that becomes I. So 2 times 4 is 8, and I times I is I squared. It's not simplified with a power of 2 or more to I, so that I squared has to become -1, and you get -8 as an answer. I'm feeling good. I believe that's the last one of those. And then I want to do the subset thing. Remember, the imaginary numbers is a subset of the real numbers. Now, we did the subsets with, imaginary is a subset of the complex numbers. We did the subsets of the real numbers, and it's the same thing. Anytime when you have a real part, an imaginary part, if the imaginary coefficient is anything other than 0, the answer is AC every time. I mean, every time. So at Socrative, you'd put A and C for number 14. But if you look at number 15, the coefficient is 0, so it's not C. So you start with the complex numbers. Remember, every set is a subset of itself, so you'd have to put A. We really emphasize that with the real numbers. And then you'd put B because of the 0i. And then if you go the B route or the real route, you have to choose between rational and irrational. 2/3 is rational. You should know it's not irrational. A lot of people over the years have told me that 2/3 is an integer. It is not an integer. You have to use the word whole number to define integers. It's the whole numbers and the negative whole numbers. Number 16, getting close to the end. This is real. So you might want to rethink this as -6 plus 0i. And again, that's because that's 0i. It's not C, so it's AB. -6 is a rational number, and it is an integer. It is not a whole number. Whole numbers are 0 and positive. I think this is the last one. Now, that's an imaginary number, so we might want to rewrite that as 0 plus I times root 40. Now, root 40 would simplify, but we really don't need it. And so the coefficient is non-zero, so it's AC again. All right, guys, I believe that's it today. I had a whole lot of fun with you. I'm sad because I hadn't seen you in a while, but I'll be happy when I see you again. All right, guys, that's it.